Okay, in this part of our topic, we'll be learning how to add vectors. Okay, so the reason why is that we have seen vectors. Well, what can we do with it? We can add them. So I'm going to choose two vectors at random. Consider vector v has components 5 and 6, and vector w has component 3 and 4. Okay, so those are two vectors that we are talking about. So as you can see, we're going to add these two vectors. So the way you're going to write down the addition of two vectors is you're going to put them this way: vector v plus vector w equals, and you're going to write down the two vectors 5 and 6 plus 3 and 4 equals, and you combine them, 5 plus 3 and 6 plus 4, which is equals then to 9 and 10 as our vector. Okay, that's our vector component here now. So our solution here will be 9 and 10 vector. So then I'm going to show this now on the graph. I'm going to use this for the graph. Okay, so let's start. I'm going to start from this part so that it can fit for this purpose. So I'm going to put here my line. Okay, and I'm going to put the other one in this direction. Now here is where the concept of additional vectors also come in, and we'll be using it much more in detail. So our first vector was what? 5 and 6. So for our purpose, we're going to start from the origin. So let me put here 1, do that in red. Okay, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the vertical axis, I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put that as my y, put that's my x. Okay, you may go farther also. Alright, so for vector v, I'm going to put 5 and 6. I go 5, 1, 2, 3, 4, 5, and 6 upwards. That's 1, 2, 3, 4, 5, 6, which is right here. That's my first vector. I'm going to be using red pen for that one. So we can see that there are two vectors being added together. And then the other vector is 3 and 4. 1, 2, 3, and 4 upwards, which is right here. Okay, so we got that vector in that direction. Now that looks kind of small there, but nevertheless, that's the idea of the vector. So what can we do with these vectors? How do we add them in the diagram? Okay, so I'm going to move this vector here. Okay, let's move this vector here. Consider that we can move this across. So if we were to move this across, that vector would be moving this direction. A vector, like we said, it has a head and it has a tail. We'll be joining this tail to this head here. So we're just moving this across. So remember, we're going 3 and 4. So let's move this vector, and it goes in this direction. So that's our vector. Okay, so we have that vector right there. Okay, so I'm going to put here my other vector which I'm joining. Okay, that's the vector. So the resultant vector will, so the component that joins them will be as follows. Okay, so I want to join from this end now to the top there and see what then happens. Okay, so I want to use that for pencil. That's kind of small, so I guess I will have to do another one so you guys can see it much better also. Okay, so therefore that is what is known as the resultant, and let's see what does this tells us. Okay, I'll put an arrow here, and the way this resultant vector is represented by saying vector v plus vector w. This is how it will be represented. Okay, So let's see what does this tell us about this resultant vector. If you notice, this is the 9 and 10. So if we go here, that says we go up 9, that's 2 3, and it went up 4, so that's to our point. Okay, so my apologies here, this is supposed to have been 8, right? So here now, so that's supposed to be 8, and so when we add this vector, we ended up with the same vector here. So graphically we can do it, we can do it algebraically. So if you count here, you get 1 2 3 4 5 6 7 8, and go upwards, which is 10. 1 2 3 4 5 6 7 8 9 10. So that's our component of the resultant vector. So this is the resultant vector.